trig functions of any angle. To define the 6 functions, we start with an angle theta in standard position and choose any point P having a coordinate of x, y on the terminal side of the angle. Remember, if it's in standard position, that means that you're starting at the vertex or the origin, and then the positive x-axis is the initial side. A perpendicular from P to the x-axis at a point Q determines a right triangle having a vertices of OPQ. We find the distance r from P parentheses x comma y close parentheses to the origin 0, 0. We use the distance formula, so r is equal to the square root of x minus 0 quantity squared plus quantity y minus 0 squared. Remember, and that's just going to give us r equals the square root of x squared plus y squared. Notice that r always has to be positive. Okay, so no matter what, r is always positive, and it's because it's the distance. So in trig function, we have a point x comma y other than the origin on the terminal side of an angle theta in standard position. The distance from point to the origin is r equals the square root of x squared plus y squared, and the 6 trig functions of the angle theta are defined as follows. Sine of theta is equal to y over r. Cosine of theta is x over r. Tan of theta is y over x, as long as x does not equal 0. Cosecant theta is the reciprocal of sine of theta, so it's r over y, and y cannot be 0. Cosine of theta is x over r, and its reciprocal is secant of theta, which is r over x, and x cannot be 0. Cotangent of theta is x over y, and y cannot be 0. Once again, if you know sine, cosine, and tangent, you know its reciprocals. So here we're going to start with our angle theta in standard position. So once again, I'm starting at the vertex, and then the positive x-axis, that's my initial side. And at the point 6, 8, so I'm going to go to point 6, 8. And that's my terminal side. And notice my theta is in quadrant 1. So I want to make sure that we are all together, that this is quadrant 1. In quadrant 1, x is positive, so x is 6, y is 8, and r will always be positive, so we're going to find r by saying that r equals the square root of x squared plus y squared. So r is equal to the square root, parentheses 6 squared, plus parentheses 8 squared. So r is equal to square root of 36 plus 64. We're going to add first. 36 plus 64 is 100. So we have square root of 100, which is 10. So we know that r is 10. So now we have sine of theta is y over r. So sine of theta is equal to y, which is 8, over r, which is 10. So we know sine of theta, so we know cosecant of theta is the reciprocal of that. So that's going to be 10/8. Cosine of theta is x over r. So x is 6, r is 10. The reciprocal of cosine of theta is secant of theta. So the reciprocal of 6 over 10 is 10 over 6. And tan of theta is equal to y over x. Y is 8, x is 6. So cotangent is the reciprocal of that, which is 6, 8. And then I'll go through and simplify each one of those. So we have that sine of theta is equal to 4/5. Cosecant of theta is equal to 5/4. Cosine of theta is equal to 3/5. Secant of theta is equal to 5/3. Tan of theta is equal to 4/3. Cotangent of theta is equal to 3/4. We're going to sketch an angle in standard position. Once again, that means we're going to start at the vertex, and then we have our positive x-axis, and then we have our point, -2 square root of 3. Well, -2 square root of 3 is approximately -3.46, comma 2. So here's -3.46, comma 2. Here's my point. This is my terminal side. And we know that that is in quadrant 2. Notice that x is -2 square root of 3, y is 2, and we'll find r. R is equal to the square root of x squared plus y squared. So r is equal to the square root of -2 square root of 3 squared plus parentheses 2 squared. If you put that all in the calculator without the radical, you should get 16. But if you want to work it by hand, you say r equals the square root. -2 squared is 4. Square root of 3 squared is 3. Plus 2 squared is 4. So we have square root of 12 plus 4, which is 16, and square root of 16 is 4. So we have that r is 4. So sine of theta is y over r. So y is 2, r is 4, simplifying that to 1/2. So we know cosecant of theta is the reciprocal of that, which is 2 over 1, or simply 2. Cosine of theta, so notice that sine of theta, since it dealt with y, it was positive. Now cosine of theta deals with x, so we'll get a negative answer or a ratio. So x is -2 square root of 3 over 4. And simplifying that, that will give me negative square root of 3 over 2. And secant of theta is going to be the reciprocal of that, so it's going to be 2 over negative square root of 3. It does not matter where you put the negative sign as long as it's in the numerator, denominator, or on the side. And when we rationalize this, we will get -2 square root of 3 over 3. Tan of theta is y, which is 2 over x, which is -2 square root of 3. Simplifying that, that's 1 over negative square root of 3. And when we rationalize this, it will be negative square root of 3 over 3. And the reciprocal of tangent is cotangent. So tangent of theta was 1 over negative square root of 3 before we rationalized it. So when we do the reciprocal of that, cotangent of theta is negative square root of 3 over 1, which is just negative square root of 3. Notice y is positive in quadrant 2, therefore sine is positive in quadrant 2, and so is cosecant. But everything else is negative because of the way the ratios work. Notice x is negative, hence cosine, and secant is negative, and then tangent is the ratio of y over x. So we get a negative solution there as well. Example 3, we're going to sketch an angle theta in standard position. So we have the vertex at 0, 0. My initial side is on the positive x-axis, and here's 0, -2, which is a quadrantal angle. So here we have sine of theta is y over r. Well, we know x is 0. We know y is -2. And we can find r by using the same formula, but r is also the distance from 0, 0 to 0, -2. And so therefore r is 2. Once again, you can use the formula, but it's so much faster to think about how many away is r from 0, 0. And notice it's just 2 away. But once again, you can use the formula and you will still get 2. So y is negative 2, r is 2, negative 2 over is equal to negative 1. And then remember, cosecant is the reciprocal of sine, so then negative 1 over understood 1 is just 1 over negative 1, which is negative 1. And then cosine of theta is x over r. X is 0, r is 2, 0 divided by 2 is 0. The reciprocal of cosine of theta is secant of theta, so r over x. So we have 2 over 0 is equal to undefined. Anytime the 0 is under, it's undefined. Tangent is y over x, so y is negative 2. X is 0. Negative 2 divided by 0 is undefined. And cotangent is x divided by y, so 0 divided by negative 2 is 0. So if the terminal side of the angle in standard position lies on a y-axis or any point on the terminal side has an x-coordinate of 0, similarly an angle with a terminal side on the x-axis and a y-coordinate at 0, for any points on the terminal side, you can always say like the point would be 1, 0, so x is 1, y 0, and r is 1 because that's the distance from the origin to the point 1, 0. Similarly, you can do the point 0, 1, x is 0, y is 1, r is 1 then. Example 4, we're going to find the value of the sixth trig function of an angle associated with 180 degrees. So here's my vertex. Here's my initial side on the positive x-axis. We know right here is my pi, or 180 degrees. I can label any point on that. And so I'm just going to label right here, negative 6, 0. So from 0, 0 to negative 6, I know that x is negative 6, y is 0, and I know r is 6. Now, the easiest is to create the point to be just negative 1, 0, just one away. So then you don't have to worry about simplifying. But here I just picked negative 6, 0, and it works. Sine of 180 degrees is y over r. 0 over 6, which is 0. Cosecant of 180 degrees is 6 over 0, which is undefined. Cosine of 180 degrees is equal to x over r, so x is negative 6, r is 6, which is negative 1. Therefore, secant of 180 degrees is a reciprocal of cosine of 180 degrees, which was negative 1. So negative 1 divided by 1, the reciprocal of that would be 1 over negative 1, which is still negative 1. Tan of 180 degrees is y divided by x. Y is 0, x is negative 6, which is 0. So cotangent of 180 degrees is going to be negative 6 divided by 0, which is undefined. Example 5, find the values of the sixth trig function for the angle 3 pi over 2. If you don't know where 3 pi over 2 is, remember pi is 180. So 3 times 180 degrees divided by 2, that gives me 270 degrees. So you have your origin, your initial side. We're going counterclockwise, and we land at 3 pi over 2, which is no quadrant, which is the same thing as 270 degrees. So here, if I pick any point, for example, if I pick the point 0, negative 1, x is 0, y is negative 1, and the distance from 0, 0 to 0, negative 1 is 1. Once again, you could also use r equals the square root of x squared plus y squared. So r equals the square root of 0 squared plus negative 1 squared. So r equals 0 squared plus -1 squared is square root of 1, which is 1. So now I have the 6 trig functions. Sine of 3 pi over 2 is y, which is -1, over r, which is 1. So -1 over -1 is -1. Cosecant of 3 pi over 2, the reciprocal of -1 is 1 over -1, which is still -1. Cosine of 3 pi over 2 is x over r. X is 0, r is 1, 0 divided by 1 is 0. Secant of 3 pi over 2 is the reciprocal of cosine of 3 pi over 2. So 0 divided by 1, the reciprocal of that is 1 over 0, which is undefined. Then we have tangent of 3 pi over 2 is equal to y divided by x. Y is -1, x is 0, so -1 divided by 0 is undefined. And cotangent of 3 pi over 2 is x divided by y, or the reciprocal of tangent of 3 pi over 2, which is 0 over -1, which is 0. In the definition of trig functions, r is the distance from the origin. So that's why you can use the distance formula to the point xy. The distance is undirected, so r is greater than 0. So r is always positive. If we choose the point xy in quadrant 1, then both x and y will be positive, and the values of all 6 functions will be positive. A point xy in the second coordinate will satisfy that x is less than 0, so x is negative, and y is greater than 0, so y is positive. This makes the value of sine and cosecant positive for quadrant 2, while all the other 4 angles or trig functions are negative. Similarly, same thing in quadrant 3. If you look, in quadrant 3, x and y are both negative, and therefore sine is negative, cosine is negative, but tangent, which is the ratio of y over x, will be positive in quadrant 3. And in quadrant 4, x is positive and y is negative. So in quadrant 4, cosine will be positive and so will secant, but everything else will be negative. So note, some students use an acronym. All students take class. So all of them are positive here. Only in quadrant 1, all of them are positive. In quadrant 2, sine and cosecant is positive. Okay, I'm talking about positive. In quadrant 3, tangent and cotangent is positive. And in quadrant 4, cosine and secant is positive. And the rest are all negative. Some students use the sentence, all students take class to remember which of the 3 basic functions are positive in each quadrant. A indicates all in quadrant 1, S represents sine in quadrant 2, T represents tangent in quadrant 3, and C stands for cosine in quadrant 4. Suppose that you have a point indicated in the quadrant. Decide whether the given ratio is positive or negative. So recall that r is equal to the square root of x squared plus y squared. That's distance. So r will, no matter what we talk about, will always be positive. So there's not a choice for r. So in the first part, it says we're in quadrant 2, which means that x is negative, y is positive. So now we're working with the ratio of y over r. So y is positive, it says, in quadrant 2. And r is always positive. And positive divided by positive is positive. So the ratio y over r will be positive in quadrant 2. We're in quadrant 3, x is negative, y is negative. The ratio y over x, well, if y is negative and x is negative, then the ratio negative divided by negative will give me a positive answer. That's for tangent. Quadrant 4, if in quadrant 4, x is positive, y is negative. The ratio r over x, where r will always be positive. X is positive in quadrant 4. And positive divided by positive is positive. It's very important to understand the signs of the trig functions. So in example 7, we're given that cosine of theta is 4/5. So what that tells me is that x is 4 and r is 5. So we know that x is 4. We don't know y yet. And we know r is 5. That's what we know so far. Now, we also know that theta is in quadrant 4. Well, what that tells me is because we're in quadrant 4, we know that in quadrant 4, x is positive, y is negative. So therefore, we know whatever answer we get, y better be negative because we're in quadrant 4. So now, to figure out how to figure out what y is, we're going to use x squared plus y squared equals r squared. So we have parentheses 4 squared plus y squared equals parentheses 5 squared. 16 plus y squared equals 25. Subtracting 16 from both sides, we get y squared equals 9. When I take the square root of both sides now, we get plus or minus. So y equals plus or minus 3. Well, we already said because we're in quadrant 4, y has to be negative 3. So now what we're looking for is sine of theta. So sine of theta is equal to y over r. So y is negative 3, r is 5. And cotangent of theta is the ratio of x over y. X is 4, y is negative 3. Example 8, we have that cotangent of theta is negative 1/2 and cosine of theta is less than 0. So we have that cotangent of theta is negative 1 over 2. Remember, the ratio would be x over y. And cosine of theta is less than 0, which means that it's saying that x over r is less than 0, so x has to be negative, so x is negative. So that's what that's telling us. So because it's saying that x is negative, then we know that x is negative 1, y is 2, and we can find r. We're going to say r is equal to the square root of x squared plus y squared. R is equal to the square root. Make sure you put your parentheses around the negative 1 plus quantity 2 squared. R is equal to negative 1 squared is 1 plus 2 squared is 4. So r is equal to square root of 5. Once again, it's always positive. And here we're finding cosecant. So cosecant of theta is equal to r over y. R is square root of 5, y is 2. Example 9. Find the 5 remaining trig function values for each angle theta. Cosine of theta is negative 3 over 5, and we're in quadrant 3. Keep in mind, in quadrant 3, x is negative, y is negative. So here we're given that cosine of theta is negative 3 over 5. That ratio is x over r. Remember, r is always positive. That makes x to be the negative 3, which we want. We don't know what y is, but we know it's negative because we're in quadrant 3. And r is 5. So I'm going to find y by saying x squared plus y squared equals r squared. We have parentheses negative 3 squared plus y squared equals parentheses 5 squared. 9 plus y squared equals 25. Subtract 9 from both sides. We have y squared equals 16. When I take the square root of both sides, we have y equals plus or minus 4. And because we're in quadrant 3, we know y is negative 4. And here we're finding all 6 trig functions. So we have sine of theta is y over r. So that's negative 4 over 5. So cosecant of theta is going to be 5 over negative 4. We were given cosine of theta was negative 3/5. So secant of theta is 5 over negative 3. And then we have tan of theta is y over x. So that's going to be negative 4 over negative 3, which is positive 4/3, and that's because we're in quadrant 3. And cotangent of theta is the reciprocal of 4/3, which is positive 3 over 4. Example 10, we're given cosecant of theta is negative 3, and cosine of theta is greater than 0. So the fact that cosecant of theta is negative 3, remember the ratio will be negative 3 over 1. So we know that the ratio for cosecant of theta is r over y. So r can't be negative 3, so therefore r has to be 3 because it has to be always positive. So therefore y has to be negative 1. And we will find x. So x is x squared plus y squared is equal to r squared. X squared plus negative 1 squared equals 3 squared. X squared plus 1 equals 9. Take 1 away from both sides. X squared equals 8. And when I take the square root of both sides, it's always plus or minus. So x equals plus or minus square root of 8. Remember, square root of 8 can be broken up into 4 times 2. So square root of 4 is 2. And then we don't know what square root of 2 is, so leave that under the radical. Now, to figure out if x is positive or negative, in the very beginning, it said that the cosine of theta is greater than 0. So that's saying that the ratio x over r is greater than 0, which means x has to be positive. So in this case, x is 2 square root of 2. So here we're given cosecant. We know what sine of theta is right off the bat. Sine of theta is 1 over negative 3. Cosine of theta is going to be 2 square root of 2 over 3. Secant of theta will be 3 over 2 square root of 2. Remember, we have to rationalize that by multiplying by square root of 2. So secant of theta will be 3 square root of 2. And then it'll be 2 times 2, which will be 4. Tan of theta will be y, which is negative 1, over x, which is 2 square root of 2. Once again, multiplying by square root of 2 over 2, we'll get negative square root of 2. And then 2 times 2 will give me 4. Cotangent of theta will be 2 square root of 2 over negative 1, or simply negative 2 square root of 2. Reference angles. Associated with every non-quadrantal angle in standard position is a positive, it has to be positive, and the word acute angle means that it has to be between 0 and 90 degrees. A reference angle for an angle theta, written 0 with the little apostrophe, is the reference angle, is a positive acute angle made from the terminal side, so keep in mind, the terminal side of the angle and the x-axis. So wherever the x-axis is what you use to create the reference angle. So if you look in quadrant 1, the reference angle and their angle is the same. In quadrant 2, to find the reference angle, you use the terminal side and the x-axis. So this little piece right here is going to be found by saying 180 minus 90, because remember right here is 180 degrees. In quadrant 3, we're going to use the x-axis and the terminal side. So this little piece right here, the way you find that is by saying the angle minus 180 degrees. And in quadrant 4 is going to be this piece right here. And to find that piece right there, you're going to say 360 minus the given angle. So first you figure out what angle, what quadrant you're in. And remember, the reference angle is always found with a reference to the x-axis. So first, I'm going to draw 147 degrees. And we know that's in quadrant 2. Well, the reason why I know that is because this is 0 degrees, this is 90 degrees, and right here is 180 degrees, and right here is 270, and then it goes back to 360. Now, to find the reference angle, we use the terminal side and the x-axis. So I'm looking for this piece right here. How many, what's this angle right here? Well, to find that angle, we're going to say 180 degrees minus 147 degrees. And that gives me that the reference angle is 33 degrees. So that little shaded region that I did, that piece right there is 33. This angle right here is 33 degrees. Example 12. Once again, I'm going to sketch 318. We know that's in quadrant 4. Once again, it's 0, 90 degrees, 180, 270, and then 360, or back to 0. So we know that this whole piece right here is 318. The reference angle is with the terminal side and the x-axis. So I'm looking for this to complete that whole circle. So that's going to be 360 degrees minus 318 degrees. And so therefore that reference angle will be is 42 degrees. Example 13, find the reference angle for 606. Well, first of all, we already know that 606 is way bigger than 360, which means the coterminal angle for this is going to be 246. So the coterminal positive angle will be 606 minus 360, so 246 degrees. So that will be in quadrant 3. So we're going to go around one time and stop right here. So to find the reference angle, we're using the x-axis and the terminal side. So we're looking for this piece right here, this angle. And to find that, we're going to say it's going to be 246 minus 180. And that gives me 66 degrees. Example 14, we're finding the reference angle for negative 300 degrees. If you don't like negative angles, you can always add 360. And you get that that will be 60 degrees. The only thing you have to remember is you're going clockwise, so you're going to end up at 60 degrees. And we're looking for the reference angle, which is this angle right here. And to do that, that's basically going to give me back 60 degrees because we're in quadrant 1. That little piece is 60 degrees. So what do we need a reference angle? Well, we can use the reference angle to evaluate trig functions, especially if they're in reference to 30, 45, and 60, because we already have the triangle from 30, 60, 90, and 45, 45, 90. To avoid sign errors, we find the trig function values of the angle, sketch it in standard position, include the reference triangle complete with appreciated values for x, y, and r. So we're going to use a reference angle to find the exact value of sine of 300. So first I'm going to sketch 300. So here's my vertex, my initial side. We have 0, 90, 180, 270, and then 300 will be between 270 and 360. To find the reference angle, we're going to use the terminal side and the x-axis. So this little piece right here we know is going to be 60 degrees because we're in quadrant 4. So it's going to be 360 minus 300 to give me 60 degrees. So that's my reference angle. Now, we know we're in quadrant 4. And opposite to 60 degrees is going to be square root of 3. I'll fix the sign in a second. And opposite to my 30 degrees, which is right here, is going to be the length of 1. And my hypotenuse, or r, is going to be 2. So we're in quadrant 4, so we know that y is negative, x is positive, and r is always positive. So we know sine of 300 degrees is equal to y over r, so it's going to be negative square root of 3 over 2. Now we're finding tangent of 5 pi over 4. So this is 0, pi over 2, pi, 3 pi over 2, 2 pi. If you don't like to think in terms of radians, you can always convert it to degrees. So 5 pi over 4 is equivalent to 225. So that's in quadrant 3. So once again, we're going to use the terminal side and the x-axis. We're looking for this angle right here. And to do that, we have 5 pi over 4 minus pi, or you can say 225 minus 180. And you should get 45, or in this case, it's pi over 4. So we know that this piece is pi over 4. I'm going to kind of bring it out here a little bit just to help see it better. So that's pi over 4, or 45 degrees. And we know that the length of pi over 4s are 1s. And r is square root of 2. But we're in quadrant 3, so x and y are both negative. And we have here that tangent of 5 pi over 4 is y, which is negative 1, over x, which is negative 1. And negative divided by negative is a positive 1. Example 17, we're finding secant of negative pi over 6. So first of all, if you don't like pi over 6, you can always say that that's negative 180 over 6. So that's going to give me negative 30 degrees. So you can always think in terms of degrees. So we know negative angles go clockwise. So negative pi over 6 is just negative 30 degrees, which is just right there. So reference angle to negative 30 degrees is just 30 degrees. Notice we're in quadrant 4. So opposite to 30 degrees is the length of 1. I'll fix this signs in a second. Opposite to 60 degrees is the length of square root of 3. And opposite to my right angle is the length of 2. Since we're in quadrant 4, y is negative. So we have that x is square root of 3, y is negative 1, and r is 2. So secant of negative pi over 6, remember secant is the ratio of r over x. So r is 2, x is square root of 3. And when we rationalize that by multiplying by square root of 3, we get 2 square root of 3 over square root of 9, which is 3. Example 18, we have tangent of 14 pi over 3. Once again, if you do not like radians, you can always convert that. Remember, pi is 180, so you hit 14 times 180 divided by 3, and you get 840. So we're basically looking for tan of 840. So I'm going to subtract 360 from that because it's going to rotate 1 time. Actually, it's going to rotate 2 times because 840 minus 360 is 480. And so it's going to, when I subtract it twice, my coterminal angle, so it's going to be 840 minus 360 minus 360, or you could have said minus 2 pi minus 2 pi, and you end up with 120. So when we're graphing 120, we're in quadrant 2, but this particular one went around twice and then it stopped. To find the reference angle, we're looking for the terminal side and the x-axis. So that's going to be 180 minus 120 will give me 60 degrees. So this length here, this angle right here, I'm just going to kind of bring it down, is 60 degrees. And we know that opposite of 60 degrees is square root of 3. Opposite of 30 degrees is the length of 1. And opposite of my right angle is 2. And we're in quadrant 2, so x is negative, y is positive, and r is positive. And here we're looking for tangent of 14 pi over 3, which is y over x. So y is square root of 3, x is negative 1, which is negative square root of 3.